Hello, in this worked example we've got a plastic box that's sitting on a steel beam. So we've got this steel beam, we raise one end slowly until the box begins to slide down the steel beam. So if the angle is measured to be 41 degrees when this box starts to slide down the ramp, we're asked to find the static coefficient of friction between this plastic box and the steel beam that it's sitting on. For this problem, the first thing we need to do, as in most of our statics problems, is to draw a free body diagram. And we're going to be looking at this at the instant before the whole box starts to slide down the ramp. So this body is going to be in equilibrium. It's right before it starts to move. So let's take and draw our free body diagram. So we've got this box, like so, and the forces acting on this box, we're going to have the gravity force, so Fg. We're going to have the normal force, and then we're going to have the friction force. And so the friction force in this whole thing is going to be what's holding this up until the instant when it moves. So F there. And the way I'm going to define the axes, rather than straight up and down, I'm going to use the x direction is down the ramp, and the y direction is going to be just perpendicular to that. So with this, we are looking at the moment before it starts to slide, and we're going to draw out our equilibrium equations. So for the sum of forces in the x, I'm going to have negative FF plus, I need to figure out the angle, and so if my ramp is at 41 degrees like this, then this gravity force is going to be 41 degrees from my y-axis. And so to find the x component, the component that's going this direction, I'm going to have Fg times the sine of 41 degrees. And that is equal to 0. And for the sum of forces in the y, I'm going to have my normal force is going positive y direction. And then I'm going to have a negative component of my gravity force. So it's going to be minus Fg times the cosine of 41 degrees. Alright, so here I've got 3 equations and 2 unknowns. I know one other thing. So at the moment before it moves, the friction force is going to be equal to the mu static value times my normal force. So FF is going to be equal to mu static times Fn. And so that is where I'm looking for mu static. So that's where I get this into my equations. So if I rewrite this top equation, what I'm going to do to get rid of this Fg, I don't know the weight of the box. If I solve both of these equations for Fg, I can get rid of that Fg in my equation. So if I rewrite this top equation, I can rewrite it as Fg is equal to Ff over the sine of 41. And Ff, remember, is mu static times Fn. So mu s times Fn over sine of 41 degrees. So Fg, if I look at the bottom equation, Fg is also equal to Fn divided by the cosine of 41. And so I can set this and this equal to one another. And that gives me the equation mu static times Fn over cosine of 41 is equal to Fn, or sorry, should be sine of 41. This is going to be Fn over the cosine of 41. And so I've got Fn on both sides. I got rid of that in my equation. And if I multiply both sides by the sine of 41, I will get mu static will be equal to the sine of 41 over the cosine of 41. So sine of something over the cosine of something is just equal to the tangent of that something. So in this case, 41 degrees. And if I find the tangent of 41 degrees, I will get a final value. Mu static is equal to approximately 0.87. And so based on this angle, I could figure out my static coefficient of friction, which is what I'm looking for in my problem. So with that, thank you for watching, and I hope to see you again.